Hi everyone, I hope you guys are doing great. So, as a part of our Postgres tutorial series, in the last lecture, we learned about creating simple functions using table types, right? Now, in this lecture, we will learn about dynamic SQL queries and using those dynamic SQL queries to return data from a function. Okay, so let's start. Let me open my PG admin. So in PG admin, you can see right now we have four databases, right? So we will use same organization database. In organization database, we have functions in app schema, right? So in the last lecture, we created one function, which was this organization data function, right? So what it was doing, just let me quickly recap those. So in this is a simple function, org data function, where we were passing the organization index, and it was giving me all the rows, all the details of that particular organization, right? So I was passing the organization index and I was getting all the details from this organization view for that particular organization, right? So now let me open the query tool and let me show you the data of our organization table. So select star from org. So I think this is the data we have, right? We have 101 rows in this table, and we in this function we were passing organization index and getting all the details of that particular organization, right? That was the objective of this simple function, organization data function. Okay. Now we will create a function which will be using the dynamic SQL queries. Okay, so we'll do same operation but with the help of dynamic SQL query. Okay, so I've already prepared some scripts. So let me just paste that and then I'll explain you guys. Okay, so this one is the first example where uh, so this is the first example, right? So let me just expand it little bit. Okay. So our function name is organization data dynamic function, right? So this is a dynamic function, right? And this is very similar to the old function, just that it is a static function, org data function, and this is a dynamic function, org data dynamic function. But on the operations of both the function is same. Right, so here also we are passing p org index as parameter. There is no change here. Okay, so only change here is in return query, we have added a new keyword called execute, right, which was not in this static function, right? And then we are taking the static SQL in a single quoted manner, right? And then taking the variable which we are passing as a concatenated variable to this SQL statement, okay, dynamic SQL statement. So that's how we prepare dynamic queries, guys. So the in dynamic query is nothing, like very different from a static query. Just that you have to get everything, whatever is static in that SQL query in a single quote, and whatever the variables are there, just use concatenation operator and then concatenate that value, right? And next, also, if you have more static query, you can add more concatenation and just add your static queries after that, right? So like that, we prepare dynamic queries, right? And here, what we are doing, the only difference is once you prepare your dynamic query, you need to execute that, right? Static queries get executed by itself. Let me just show you old function again. So here, see, there's no execute keyword, right? So this is our query. So we are just doing return query, right? It gets executed automatically, right? But in case of dynamic query, we had to write this keyword execute, then only it will get executed, right? So let me just create this function and show you guys the output. Okay, so function got created. So we will be calling it for a particular organization index, that is one. So see, we are able to see the data, right? So we can see organization index is one and all the data which is very much similar or exactly same output which is from the static function, right? We can also check it calling for some other organization index, right? So see, it is giving now data for organization index 2, right? So I hope you understood how to prepare dynamic queries and how to execute that, right? There is one more example which is a little bit, more well formatted dynamic query. So let me just paste that and I'll explain you what is the difference here. Or let me just open a new tab and so that I can show you what is the difference. So see, in this example, everything is same, just that what I have done in declare statement, I have declared a variable called local variable statement, which is of character varying type, right? And I have kept size as 2000. You can keep the size as per, size, expected size of your SQL query, right? And then in that LV statement I have put that static query. Okay, so this LV statement would be storing my static no SQL query, and then while executing I'm using that variable stored variable uh, to uh, do the execution of that SQL query, right? So here we are directly executing our complete dynamic SQL query. State that it's a well for to do the well formation in complex functions or complex queries, right? So you can take all the LV, you can take all your SQL, you can first prepare your dynamic SQL statements in a variable, right? Once it is prepared very well, then you can execute it, right? You can execute it and see in this example I can also take out this pog index from here, right? And I can just add it here. This is also good. This should also work, right? So I'm preparing complete SQL query and then I'm just executing this LV statement, right? Or you can do like this also, that you can concatenate at the runtime also, right? So whatever this thing, it should be like a complete prepared dynamic SQL statement which you are going to execute, right? So let me just run this function and I'll show you the output. So function got created, right? So let me just show you the output. So I'm running for organization index 2. So you can see we are able to get the output for organization index 2, right? So isn't it awesome, guys, right? So I think we are able to prepare dynamic SQL queries and execute it well, right? Now we will understand the advantage of dynamic SQL query, right? Why we use dynamic SQL query? Why don't we use only static queries, right? So I have list down some advantages. So let me just paste, copy, paste it, and then I'll explain you. So advantages of dynamic SQL query, it's easy to maintain and write, right? It applies modularity, right? It increases reusability, right? So once you create a dynamic function, right? So it can be reusable. It looks like applying modularity, right? One function can be called in other functions, right? Easy to maintain, right? Easy to write. And second advantage is you can call that in other functions, right? You can call that in other functions, while in normal function you can, when you call other function, right, it gets execute and the result is returned in calling function. What I mean to say, suppose you have a function f1, right? So function f1 is there and there is one more function, function f2, right? So if both functions are static, right, and if you are calling function f1 in function f2, right, then function f1 will return the result and that result can be used in function f2. That is the static nature of function calling. But if your function f1 is dynamic and f2 is also dynamic, so it's possible that function f1 can return just the query and not the executed result, right? It will just result the query, prepared SQL query, okay? And here in function f2, we will call that function f1, we will store the generated query, and here in function f2, we are going to execute both dynamic SQL query from function f1, which we got in this LV, and the dynamic SQL query which I got in function 2, right? So both together we can take it together and then we can execute at one time in final function, right? So this is the advantage of dynamic functions. I will also show you the demo of this one. Okay, so let me just open the tab. Okay, so let me just open the tab, sorry again, and let me just create function f1 and f2. Okay, so this is my function f1. This is my function f1 and this function or org data f1 function. So I'm passing p founded date. Okay, so in organization data, if you guys remember organization data, let me just check it quickly. So in organization data, we have organization's record, right? Every organization's record, and each organization has their organization index as well as each organization has their founded date, where in which year it was founded, and number of employees, right? So we are going to use these two parameters in our function, founded date and number of employees. Okay. So here, what I'm trying to do is passing founded date in this function as a parameter, and then in this function, I am preparing the dynamic SQL query, which is select star from this view where founded date greater than this founded date, whichever I'm passing, right? So suppose I can pass year 2000, right? So whatever organization which are greater than 2000, right? So that SQL query will be generated here, right? And it will be stored in this LV statement, and I'm not executing that no LV statement. I'm just returning that dynamic query here. See in function f1, I'm not executing it, right? So that's why its return type also, if you check, is character varying, right? It's not table type data, right? It's a character varying, right? So it will just return this complete prepared statement, that is select star from this view where founded date greater than the parameter which I'm passing it f1 p founded, right? So let me just create this function, guys, then I will show you the output. So our function got created. Let me just run it. I'm passing 2000 as a year, so let me just run it. So let's check the output. So in the output, you can see output is coming as select star from this app org view OB. OB is the alias where OB dot founded greater than 2000, right? So it has generated a query, right? But we have not executed it. We are just getting this generated query in the output. Now we will use this query in function f2, and we'll. So let me just create the function f2, and then I will show how we are using f1 query in f2. Okay, so let me just open a new tab and let me just paste it here. So here you can see I'm creating a new function org data f2 function where I'm passing two parameter. One is found date, founded year, and another one is number of employees, right? Both are begin type of data type, right? And what we are returning the table type of returns, right? Record type of return is there. That means we are going to return the complete tabular data, right? Now so there is a local variable LV statement, right, which has a size of 2000. In LV statement, I am calling the function f1 with p founded date, which is the parameter in this f2 function. I'm passing this to this f1 function and storing the query which this f1 function is returning into LV statement, right? This query, whatever is the output, it will get stored in this LV statement, right? Now I'm checking the second parameter, which is number of employees. If p number of employees is not null, if the parameter passed is not null, then this LV statement, this is the LV statement, right? And then I'm concatenating one more AND clause, and OV number of employees greater than p number of employees, right? P number of employees, I'm passing the second parameter, right? So number of employees should be greater than the number of employees which is passed in parameter, right? So this is the AND clause getting added in function f2, and LV statement is storing the output of function f1, right? So here in this LV statement we have combined result of f1 and f2, right? Now I'm doing what? Now here I am executing in F2. Finally, when I have combined result, I am executing it here, right? So let me just create this function, then I'll show you why we called F1 in F2. So function f2 got created, right? So now let me call this function with two parameter. Year first founded 2000 and number of employees is 5000, right? So let me just call it. See, it is giving me 17 rows. That means there are 17 companies which are founded after 2000 and have employees greater than 5000, right? So there are 17 organizations like that, right? But what if I just want to, pass the parameter only founded year? That means I want to get all the organization which are founded after 2000, but I want to skip this one condition, which is number of employees greater than 5000, right? So in that case, I can pass null in p number of employees, right? In the same function, I can pass null in the second parameter, and it will just apply one condition, that is founded at greater than 2000. So earlier we had 17 rows. Let me run this output. So this time we have 38 rows, right? So this time we are just applying the founded date year. So this is giving me all the organization which are founded after 2000, but we are not checking number of employees. See, number of employees is 921, right? Which is less than 5000, right? So I hope you guys understood the concept of dynamic preparing dynamic queries and how to execute the dynamic queries, right, in function, how to return the result, right, how we can return the dynamic queries using character varying in one function, right? So in the next lecture, guys, we will learn about using bind variables, extending this dynamic SQL queries knowledge and using bind variables in the functions. Okay. So if you guys like this video, please subscribe my channel. Yeah. And thank you, guys.